Hey, how's everyone doing? I think we have the audio working now. Well, I made a mistake. Okay, yeah, so hopefully the audio is working as it should now. The volume should be much more, much improved from last time. I know we had some people with issues regarding volume levels, but yeah, it should be good now. How's everyone doing this fine morning out here in Japan? Evening out in the U.S. I assume very early in the morning in Europe. Yeah, we're just gonna give some time for people to come on in. I just started the stream, but so today not doing anything incredibly exciting, but nevertheless incredibly essential. We're gonna be basically dealing with reading and writing files. Something I haven't done yet in Zig myself, but it should be very similar to C. Um, Considering it'll be working with the same operating systems, Windows, Linux, etc., etc. Okay, and to some of the things too, I'm gonna want to look into actually serializing our game data out into JSON format, which I decided is going to be the text file format I want to use for, at least for now, for storing the game data. It makes it easier to edit by hand and such, and to diff, so we can see changes in properties and stuff like that pretty easily, because ideally each property will be on its own line, which makes diff tool makes it more readily editable by a diff tool. Okay, which I think is incredibly important for game development. Some engines use binary formats for everything, even for uncooked assets, and it means that you can't really diff them. Looking at you, Unreal Engine. Okay, and yeah, we need to look into also, yeah, we can see if we can actually serialize out the character data, not just any generic data structure, but we want to like be able to serialize and then write out and read character data into storage. Then maybe I would look into some like memory allocation stuff in regards to like loading data. Yeah. But yeah, that's a general overview of what's gonna happen today. How's everyone out there doing? Give some more time for people to come in. So the plan for today, how to do this stuff, is we're gonna look at some documentation, run some tests, and then maybe we'll implement code into our game directly. I haven't decided yet. Hey, Backdrift, thanks for coming by. Let me see. So basically, my strategy for this is I'm going to build a Scratch file for running tests. These are not things we're actually testing our game code. Yo, what's up, Red Muffler Man? Yeah, so I'm just going to make like a Scratch test file, not like a normal test in the sense that we're going to have tests running to verify, validate functionality for our game. This is more of like stuff for learning, right? So the way I'm going to do this is, looks like we have different folders here. I'm going to make a new source folder. I'm going to put it under source. It's not really our game source, so what I'm going to do is make a new folder under here. Can I make a new folder? Oh, I have to do it like this. New folder. Let's prototyping. So prototyping, I don't want it under the source. I want to put it under the main fighting game. So I think, can I move it up here? No, I don't want to move the docs. I want to move into, wait, did it move it? Oh, here we go. Yeah. I want to move the docs. I just want to move it into, not into Relib either. Move it into our main. Can I do that? Okay. Yeah, I want to move that there. Okay, there we go. Okay, so we got prototyping, and under here I want a new file. Let's see. Okay, so we have that there, and then I'm going to include some standard things that we would have in other files. Just standard. For now, we just have the standard lib, and let's copy some of our tests just to see how many tests in main. I don't have any tests in main or game, right? Yeah, so just to get things going, to get some momentum going along. Okay, let's just test writing file, reading file. Okay, and we're just going to do something like this, and let's just run the test real quick to see what happens. Zig test proto. What does it say here? So all tests pass right now. We shouldn't pass. We want to, basically this is not really testing if any functionality works or not. It's just so that we can learn how to do file reading and writing. Okay, so luckily beforehand, I looked up some file reading writing stuff, and let's just start with writing a file. So let's open a file and write it. By the way, I apologize for doing such basic stuff before it comes to programming, but this being a new language for me and a lot of people, I just want to start from the very bottom on everything so we can build up from there. I know it's very tedious, but I think it's essential. So let's look at, well, first we need to look how to open a file. So in Zig, we have a standard open function like this. It takes a file path, some flags, and what perm is. Well, open and possibly keep a file. Keeps trying if it gets interrupted. Okay. These are just some errors that it pops out. So let's just jump in and code something here. So we could do standard os.open. So we want to open a file. Can we just do something like this? Let's see. Let's see. Output dot. Let's just do output. Whoops. txt. Interesting thing. I didn't see anything about opening for reading or writing. So, by the way, this is a standard language documentation for Zig. Okay, it doesn't look like there's much as far as documentation going here. So we're gonna have to look at the actual source code for Zig. So see. We should be able to just jump in here. Open. So I need to test what's open. That's my question. So it's open there. So I wonder if open test are in a different file. Yeah, it looks like this is just an implementation, right? So I wonder if they even do have tests for open and write, or sorry, open, read, and write. Well, I found like a thread on Stack Overflow that has something about it. So let's just look at what they suggested here. They have an allocator they set up here, and then they get a file path, and then they open a file, and they set up the close, and they read from the file and do some stuff on it. So they use a function called open file absolute path. So I guess it takes a absolute path instead of a local path. That's fine. So it looks like they have to like get the path first. I'm not going to think about that too much right now. It looks like there's some options, and the option they pass in is read equals true. Let's go back to open. Let's see. So flags, it says U32 here. So is this what the version we're using here? Is that the problem? Let's see. So it looks like maybe this function doesn't exist anymore. This is old, potentially. When's this come? It's from 2001, and Zig is constantly going. Oh, we got learn Zig. Okay, we have this. It's gonna be cool too. So, okay, let's create and open a file in our current working directory. Write to it and read from it. That's what I actually want to do. So they open a file by creating the file like this, and they close it. They defer closing it, and they seek and do some stuff with it. The function absolute path is similar. It does exist. Okay. Does he actually use the open function? So they just open, they use this create file function, file systems. Okay. They open directory here. It's interesting that they have, so yeah, okay. Oops. This path. It's interesting that they don't document the flags. This is U32 instead of a struct. Huh. How are we supposed to know the options if it's just a U32? That's what I don't get. Now we're working a language that's like in development, trying to find information. It's kind of difficult sometimes. Open, is it? So it's open file. Open file absolute path is not there. Okay, that's interesting. What if they removed it? So again, the flags here, they're going to pass into open W, depending on the situation, or open Z, depending on the situation. Open Z takes, again, flags to U32. Or open W function. So this is open for Windows. What happens with the flags? Open options from flags. Oh, so they have this function that converts flags. Okay. Depending on what the flags are. So it's a platform specific flag function. So they're doing like bit masks to get the actual flags, which is interesting. So where are we at? Where's that documentation I was looking at? I don't look at that. This is what I was looking for. Yeah, I'm gonna save that for later. Looking up some documentation can be time consuming sometimes. So it's interesting. I'm pretty sure this like fscwd create file thing is also. So these flags here, it's a struct with the property of read being set to true, but I mean, stuff not being in documentation makes it kind of difficult to. Obviously I can guess there's a read and write. Okay, let's just go with it for now because, yeah, I'm not sure about the, so we want to say write to true, okay? And, whoops. We're going to open write to true. So we're going to open file. Go back to here. Where's open? And should return error or I32. I guess the file handle. So I think that's the way to do it. Not entirely sure. So let's defer closing it. Yeah, defer. The thing is, like, oh, you can do like const. Does that make any sense at all? Yeah, the file handle shouldn't change. So we could defer file.close maybe? I don't know. Though it seems like create file returns not just a file handle, but a structure. Okay. Let's go look at the documentation a little bit more. Let me come back here. So it does return this file structure. Interesting. So let's use that one instead. Let's not just do open. I do want to learn how to use the basic open though. Maybe. Hold on real quick. Is there an open? So there's open file absolute. So okay. So look at direct open file to function operates in both absolute and relative paths. Search at the path. Okay, so what about open file? Does that return a file handle? It does. It opens a file for reading and writing without attempting to create a new file. Okay, to create a new file, see create file. Got it. So we can do, well, in theory, we can do standard fs directory. So instead of this, we can do fs directory open file. Okay. We have flags. So we have a path. Let's just say open.txt and then flags, open flags. Okay, so here flags can actually just be something that's useful here. So open flags. So these are the options. Open mode, read only. Okay. It's enum. So mode. So what mode equals going to equal fs.file open flags. Do we not have? Oh, fs.file. Oh. This is fs file open mode. Okay. Fs file. Oh, wait. It's really. Let's just guess for now that it's not finding it. Let's just see what happens here. Okay. M defer closing, second of work, zig error expected type of. So we can't just pass a string in. It has to be something else. Oops. It has to be a subpath. What? Hold on. What is C? What's CWD? Current working directory. Current working directory. Got it. So we don't do duck directory. Do current working directory. Okay, that makes sense. Does it let us do things? So no member name mode instruct open flags. Okay. No member name mode instruct open flags. Hold on a second. Can I get another version of the STD? Because I think but we're a little bit version back, so can we change the version here? Oh, yeah, let's do this one. I don't want to do master. Okay. Okay, so it's read write bool. So they changed it. Okay. So it was read equals true. So it was a boolean instead of a mode. Got it. They did change that. Okay. So let's make a new, let's go to, I wonder if that's let's try this. Let's make a new file output. Oh, sorry. Okay. File not found. Okay, that makes sense. What if I move? What if I do that? So it passed. Okay, cool. We'd have to change the current working directory to the prototyping folder. That's fine. But this is just a test of whether or not this works. Okay. Can we read from the file? Oh, that's, yeah. Can we read from the file? So let's test reading. So we can open a file, and that's actually test reading. So let's go look at this Stack Overflow real quick. So there's different way to read. There's a buffer reader. So it's buffered reading. Okay. So what are they doing here? They are calling this, getting the stream from it, and then they're just looping everything by. I just want to print out the entire file. I guess this is one way to do it. Yeah, I forgot to consider there's many different ways of reading a file. I want to read everything for now into into a flat buffer, But I think things I got to consider is when we're reading JSON file, maybe we don't necessarily want to read the entire file into memory at once. You might have to read it part by part while we're parsing the JSON. And depending on what the JSON parser takes, we have to consider which reader we use. Okay. So this is standard EI buffer reader. Okay. Standard in out buffer reader. Let's go here. Okay, let's look at this. What is it? What was it called? Buffer reader? Buffer reader. No such a thing exists. Buffered reader. Buffered reader. Okay, makes more sense. Buffered reader. Okay, no documentation here. But it takes an underlying stream and does something. Got it. So any other readers? There's a bit reader, buffered reader. Okay. So standard in out. So a standard in out dot buffered reader. It takes, what does it take? It takes a stream. So file dot, what do we got? A lot of things. Is this one going to stream here? No. But it's mentioned here, it's called reader. So itself has a reader. And yeah. What was it again? File was it? So a file has a reader. And a reader has a bunch of functions. Okay. This is going into a lot of details about how the file works. But whatever, we're just going to follow by example at this point to get things going. So we're going to say var reader equals this, and then they get the, so it's like you use the EO buffered reader to read from the reader, and then you get the reader part of the buff reader. Okay, gotcha. I think we don't even have to do that actually. We just do this, and then we can go. So let's make our own buffer here. Yeah, dated 1024 of U8, right? Yeah. And then we can do like what they're doing here. Whoops. Not that. And we can use the while loop like it says here. We should be able to do try reader dot. Yeah, it's a little confusing, I guess. We'll use read until delimiter or end of file. Okay, read until delimiter or end of file. Or read into the buffer for this. I guess it takes a delimiter, takes something. So hold on. And then we can do something like, wait, it reads into the buffer. And then we technically could just do, and then we can just, let's just do standard.debug. Print. I think it's like, what was this? The format for it was, I forget about this. The format is. Do we use it anywhere? Oh, wait, the format is something like this. And we're just going to print out the string. Sorry. I'm going to use this and then the buffer. Can we do that? That's the question. It returns. Really? Does that even? Oh. Oh. Okay. So it does read into a thing. Got it. So instead of doing that, we can do something like line and print it out. Oops. just the test reading from the file. Okay, that's one way of doing it. Read until delimiter. How do I want to do this? All right, so let's see what the Json code actually would use. Because there's so many different ways of reading and writing a file. I don't want to get stuck in just like looking at all that stuff. So let's go. So I know Json must take more than just a string buffer. It's got to have something way to read it from a stream, just in case like the JSON file is too big. Okay, hold on. So as a parser, okay, parse function takes input. So here it's just, it does just take a plain string. Is there any way to parse? So this is a slice with a fixed size, so it wouldn't be able to just to parse a file directly. So great. Streaming parser, here we go. So that's what I was looking for. We need some kind of streaming parser. Reset feed. So you would pass in a streaming parser, give another byte to the parser, obtain any new tokens. This may be really okay. So we have a streaming parser character. I don't know why character would pass in. Oh, so this gives it directly. Let's see if anybody's used this, because I'm not quite sure how to use it. Hold on. See how it actually get used. Not loading. Oh. That's not going to help me very much at this moment. Well, sorry, give me a second here, y'all. Exploring this stuff does take time, unfortunately. So there's types under the JSON. I bet I can even check here, like standard JSON.streaming parser. What does it streaming parser have? It has feed, init, reset, state. Okay. It has a state. What is the state? Okay. Technically, you could randomly you could just feed it in like this, passing in a character for each character in the stream. So you could have a while loop technically if you wanted to do it, but I don't know if I want to do that. And then it has a token. It returns a token. So it's not. I don't feel like we would call that directly. What does reset do? How would this be handled? Is one of the things we got to think about, because we have to consider having very large JSON files. potentially files larger than we want to store in temporary buffers, right? Really, that doesn't seem. So no example of using streaming parser. Is this a zig thing? I'm just looking at this. Okay. Yeah, it doesn't really look like anything I could use. Okay, that's Java too. What am I getting Java? Okay. That's not helping me very much. A small wrapper over stream parser for full slices returns a stream of JSON tokens. So what is this exactly? It looks like it's a small wrapper over a streaming parser. Is that part of the library? Center library? Trying to find good documentation is hard, apparently. In their test example here, they're just getting a clean payload like this, and then they tokenize this token stream given. Wait, token stream. Is that what we're looking for? Is token stream? Token stream. So it's a struct that has a parser and a slice, and okay. Let's see if we find information on that. So you can initialize a stream to a slice, it looks like. Yeah, you pass on a slice there. I don't see anything about allocation, though. Maybe it's not needed. And then you can parse by passing the stream in. What's interesting that oh, it takes a token stream type. So wait, hold on. So parse takes a, oh, it can take tokens as any type. Oh, okay. So what can we? How do we get to the point where we can actually get slices to pass into the JSON parser? Let me think about this. So the token stream struct, it has a slice that it works on. But I'm trying to think about continuous parsing of a stream. Just so trying to work backwards here, right? I really wish this was going faster, but unfortunately it's one of those things where you don't know what you don't know, so it does take time. You know, it would be much easier if I just decided to read and write a fixed buffer, but again, we could run into, if we're loading a bunch of files in parallel, we can run into memory issues, right? Man, I don't know if it's something to worry too much about for this project, but the whole point is to actually think about this stuff, right? That's the important thing. It's more important than the final project itself. Um, to actually think deeply about these problems is really important, especially from the base issues. So, it's an important skill to be able to read through documentation and find what you need. Examples do help, but just following examples blindly doesn't necessarily lead to something that you can actually use for your project, right? You can hack stuff together, but it doesn't. When there's an actual problem you need to solve, you won't understand how to solve it necessarily if you just do that. So I think it's better to always start at least from some bare minimum and then build up from that. Okay. So I was looking at this chapter again. It's interesting. For me, a common case would to be this is something you'd almost never do. I know it's an example, but you wouldn't just have JSON sitting in a string in your program like this, right? You'd be streaming in from some file or from some network source. Okay. So I need to learn how. Thinking about it, I need to learn what is the strategy that Zig used for reading and writing files, large files. Did somebody write about that? Reading, writing, large files, Zig. Okay. This is not what I want. Okay, let's go back to file system. So, like we saw before, they use this like thing to create a file. They close it. Okay. And they seek in the file with the 0, and then they read all of the file, right? So, let's do this. Let's go back here for a second. Let's not do this. Let's just read the whole file for now using this read all call. I should be able to do that. So I should be able to do file to read all, and it passes in the buffer that we already set up before. And we do like bytes read equals this. There's an equal thing here. Oh, okay. And I just want to do, for now, I just want to print it all out. Do that and then do buffer. Actually, Zig doesn't have a null terminated thing, so we're just going to assume for now 1024 bytes. Oh. I forget how, yeah, so we can do, let's just see, message equals, we can do buffer 0 to, shouldn't it be 0 to bytes read? I think that we can make a slice like that, then read message. Does that work? Oh, reader. Where's the reader? I don't care about the reader. Get rid of the reader. Oh. Did you try? cannot format slice without a specifier. Oh, so I have to do that for string. Okay. Well, let's do, I don't even need Notepad, honestly. We'll just open the file directly. So it's this, do we see testing a thing? Testing a thing. Okay. It's printed testing a thing. That worked. Let's just make sure we have 2 lines so it's clear. Printed testing a thing. Test if passed. Great, fantastic. I think technically I want to check on something on like slices, because is this, if we had like 1 byte read, right? It would just be 0 to 0. Let me double check that real quick. Zig slices. Slices and zig are just a way to store a slice of an array, basically, and it is a start pointer and a size, I believe, is how it's stored. You can do like 0 to 5. Sorry, just reviewing some stuff real quick. There's an array in the slice. Yeah, okay, so you can do it. You can do like array length, and that's fine. It's not the end. It's the array length. I just want to make sure that was the case. Okay. Cool. So we can read. That's fine. We just shown we could do that. Yeah. Okay. Let's just try writing real quick. Let's just set this right to true. Actually, this should be input, but I might mess with that in a bit. So this would only open a file that exists already. Otherwise, this can throw an error. But we'll get on to that later. So instead of read all, let's try writing to it. Let's try to write a buffer. So instead of having a buffer like this, let's have message equal to something like that, and let's end it with a end of file. I don't actually know how we handle end of file in this case. Let's just hope. Hoping is not the greatest thing to do in the world, but let's see what the documentation here says, or at least let's see what writing does. So you can write all like that. So you can do try file.write all. Let's say message. Okay, does that work? Oh, sorry, we need to actually have a hold on real quick. Okay, let's just save that. Okay, testing input file with a message. Okay, test writing a file. That passed as well. So what does output have? A test message that we wrote. Cool. So that works. We know we can just write a file. That's no problem. Okay. So there's the basic ways we can test reading and writing a file. Now, what I want to test is doing some JSON stuff with it, right? Let's test reading a JSON. Let's just test writing first. Test writing a struct to a JSON file. Okay. I think we can do something like, well, so const test struct equals a struct with let's have a being a u int32. Is that right? Oh, this is say int32, or is it i32? Okay, and b equals, let's say b is a string. So b is a string that is a u8. What if it's any string? Let's just say it's a fixed size string. So let's just say it's 32 length string of u8s. That should be right, I think. Hold on. Sorry, I'm just thinking to myself on a lot of these things. I'll try to explain as much as I can. On these pub constant. Anyway, it should be fine here. Okay. And then we could do var data, which is test, can be equal to a test JSON struct with a equal to 42 and b equals the world. Okay. The world. I don't know why it's called the world, but it is the world. And then we'll try to, let's open a file for writing, first of all. And then we need to use JSON to write to the file. Well, first thing we need to do is we need to do JSON.stringify. I think stringify is the thing I'm thinking of. Let's say data. I think const output data equals this, and I think we can do file.write all, maybe put data. This is maybe that'll work. Actually, we need a path for it, right? Well, actually, let's not. Sorry. Okay, let's just test output.json, and we stringify it, then we write all. Is that gonna work? Error. Expecting type 32 found. Okay. So it can't be 32. It can be like this. It could be a slice. Does that work? Am I crazy? It is throwing an error, but is that the right way to do it? I always forget. Expected 3. So stringify takes more. Takes a value any type, stringify options, output stream any type. So it needs, okay, so it doesn't just return a thing. We need an out stream. Okay. So how do they write? They do stringify. Oh, we need a string writer. So this is another streaming kind of thing, right? So we need to have the data, the options, which I'm not doing any options for now. That just means we're not setting, we're just taking all the defaults. And we need a string writer. So you have a buffer that is of a U8 type. Oh, you can do inline struct like this. I'm gonna do that instead. Oops. So we can have like an inline struct. Oops. That doesn't have an, yeah. Oh, they already defined place. Never mind, it's not inline. I'm crazy. Whoops, that was just initializing. Okay, that was the same thing I was doing here. right here. Okay. By the way, sorry, my voice might have got quieter here. About an hour into the stream. Okay, it should be fine. Anybody have any questions, go ahead and ask at any point. I'm just, just trying to get down stuff into text that we can use later. Let's see. So the first thing to do is make a buffer. We have a buffer. Well, we should have a buffer. Now we need to make a buffer again, actually. Oops. Let's just make a buffer. We do need a buffer. Okay, so we have our buffer. Just for storing bytes. I made it a kilobyte because why not? Yeah, and then we need an allocator, looks like. And fixed. Oh, so they're going to use the buffer as the allocator. So this is just using it for an allocator. Okay. Let's just do that. Let's use the buffer for the allocator. The storage, right? Fixed buffer allocator. Makes sense. Sounds useful. Then we have a string. They created a new array list, actually. An array list, huh? That uses this allocator. Okay. I'm just going to take it. So they created an array list using this allocator, which we've done before. Things like that. We could use other allocators, but we're going to use this fixed buffer allocator in this case. And then they stringify. And they use the string.writer. So string.writer means we're writing to the buffer, right? So they're going through it. It's interesting. So they're going through an array list. Using an array list. They're using an array list ability to write to its memory. As writer is, right? This should be a writer, yeah. Yeah, writer. So it's just appending to the list. An array list can be treated like, you can treat it like a string effectively, right? It's just that it has dynamically allocated memory. Okay. And yeah, we have output data. Well, I didn't want to do that actually, so I don't care about the output data, but we're just going to write the buffer, right? Is that going to work? 45. Okay, we got to try that again because it is using dynamic memory. Error expected. It's 40 expected type this, but found. So 47. Actually, yeah, we don't. So we need a slice of this. So we need a slice from 0 to string.items. What is it? I thought it was string.items. Hold on. Let's look at our other code. Length is length. Okay, it's not length. Okay. So it's kind of a hackish at the moment, but I know I can get the number of items from this array list. So we know how much to actually write. And the write all needs a size. Well, yeah, it takes a file. Yeah, it needs a slice here. You can see it doesn't take a just a fixed length array. Okay. We do try here as well. Okay, what's the problem? So this failed with some kind of error. I didn't see what the error was. Oh, here we go. File not found. Okay, that's what I would kind of expect. So let's do test output dot. So instead of using open, we want to use open. Not just open. We want to use create. We want to create file. Create file. So create file should do it. It should actually open it for us. Not open, but create file. And maybe that'll work. No member name write. There's a read, but not a write. What does this create file do here? Let's just say we don't even need anything here. So it should be able to write to it at least, right? Maybe it's a bad assumption. Okay, all three tests pass. So you can see here we have a test output.json. It looks like this. Great. So we got writing JSON working. Okay. If we look at our planning document, rewriting text files from storage, look into how to deal with file paths. Okay. I'm going to put down to do for now is like how to look into how to deal with large reading, parsing large files with JSON. Because we're going to at some point, you're going to want to be able to like read stuff into JSON in a streaming mode, not from just a very large buffer. But for now, we'll ignore that. Okay. Yeah, so let's just say we've done this. We haven't looked into file paths. We serialized the JSON. We haven't done this yet. Give me a short. Let me have a short little break, and then I'll come right back and continue where I left off. I want to get to reading JSON and see if that works. Okay, I am back. If you're still with me, let's deal with reading a JSON file. So let's go copy this output JSON. Let's duplicate. Oh, sorry. Let's just go to prototype real quick. Copy output. Oh, JSON, right? To sorry. Okay. So let's go back to our reading and writing. Let's look at test input. It should be this value right here. Okay, let's go back to our reading and writing stuff. let's copy reading text here and make that into a JSON parser. So, oops, well, into something that's going to parse JSON. Test. Okay, so we're going to do the reading here. I think it's before. I don't know if we're going to use the buffer or not. But let's see what they're doing here as far as JSON parsing. So this is stringifying. This is parsing. So they just do JSON.parse on a stream. So we're going to have to tokenize a stream. So we can tokenize a stream given a buffer. Right. Okay, so we do bytes read message, and we're going to do test input.json. Okay. And we're going to do bytes read, and we're going to read all of it. And then, so at this point, when I was talking about before about streaming in data, the actual reading part is going to be something that needs to be handled if for larger files. We can't just read into a giant buffer, giving memory limitations with very, very large files. Because game data can get very, very large potentially. So yeah, okay. Or at least you have like a lot of files you want to, read at once or in parallel. So, and there are memory limitations there. Okay. Yeah. So we've done that, and we have our message. Instead of just printing this out, what you want to do is we want to do something like standard json.parse. Actually, we need to tokenize it first, right? Tokenizing means that it turns into symbols that the JSON parser can actually handle. So first we need to do var stream equals standard json.tokenize our stream. And what does it take? Oh, we need a new token streamer, tokenizer, I guess. And we're going to use our message, which is just a slice or just a string. And then we should be able to do just what they're doing here. So const data equals standard json.parse. We're going to parse using the stream, right? Oh, what is place? Oh, what is x then? Oh, we need to tell it the type actually. So the type is going to be the test JSON struct, right? In C++, it would be something like a template argument here, but there's no template arguments in Zig. You just use plain old Zig compile time syntax. And then it takes a stream, and then it takes a list of parameters. We're not gonna pass that in. So then we can also do what they're doing here, which is like try expect data dot, and doesn't know what that is actually, but data dot a to equal 42, and then try expect data dot b. Can we string compare like this? I don't know. The world, and that should be what we want. And let's see what happens. Use undeclared expect. Oh, it should be standard.test.expect, right? Or, whoops. What was it? Other stuff. What? Actually, that's something. Standard testing expect. That's right. Okay. Standard.testing. Honestly, we probably can just. Well, anyway. Standard testing dot expect. Okay. Do that. And error. Does not support field access. Oh. I need to try to get rid of that error. Operator not allowed for type constant U8. Okay. String comparison. What's string? Oh, I don't know how to do string comparison actually. Zig string comparison. So wait, we can't. Operator not allowed for type constant U8. Which side? Is it both U8? I don't know. Hold on. So I thought you can just do a comparison like that. Okay. What's the problem? Operator not allowed for type. That does make it a string. Maybe because the slices are not a fixed size. Let's look at zig string test. Maybe there is a test string thing. Try standard testing string. Expect equals strings. Okay, got it. Let's do that. Maybe this will work. Just a way to skirt around this issue. Maybe it works with slices of any size. It did not like what I was throwing at it, apparently. Allocator required. Allocator required. At what line? 66. So we don't have an allocator. They didn't mention an allocator here, but that makes sense. We would need an allocator. Huh. Oh, you need an allocator because it's string. Yeah, strings need an allocator. Gotcha. Forgot about that. Yeah, so when you're parsing JSON, strings need an allocator. Gotcha. So, where is that explained at? I don't think they explained it here. Oh yeah, it says JSON parser requires an allocator. So yeah, they have a test allocator. Yeah, you can just use the test allocator. So when we parse, we pass an allocator dot allocate. Oops. Allocator equals standard testing dot test. What's a test allocator? I'm just gonna guess that's the allocator that we can use. We want to have a proper allocator we set up here ourselves. You know what? Let's just do that. Let's just like give ourselves a nice little allocator. Let's just make an allocator for ourselves. Okay. And okay. So we have ourselves an allocator. Oh, we were declared buffer twice. Okay. That makes sense. This is called the alloc buffer. That really okay. So it passed. Yay! So we have a working thing, a test code for this stuff. Now, just to validate that it's not randomly working, it's actually doing what we think it's doing. Let's jump back to our file. Let's modify this test input. Change to 43. Does it fail? Yeah, it failed. This failed. Detect for 42. That failed. The earth. Does that fail too? Yes, it failed at testing the world. And change it back. It works again. Yo, what's up, Comic Man? How you doing? Thanks for dropping by. Getting close to finishing up here, sadly. So on our agenda, what we have done. So just to quickly review and mark off some things. So we've tested reading and writing files from storage. We didn't look at anything with any file paths, but we did serialize to JSON and read from JSON. That was the main goal for today. I did want to get around to dealing with our actual character data, but we do have problems with larger files, or eventually we'll have to deal with those kind of problems. so we don't have to use these fixed memory buffers all over the place for reading and writing files, because we don't necessarily know what the size of the file is that we're reading. First of all, not only is the files that we're reading and writing could potentially be large, but we don't know the size, and we would have to create buffers that are efficiently large enough to store them. Of course, we could use operating system dynamic memory, but that's slow. That would slow down reading and writing files for our game, or it just make load times worse potentially. So, yeah, I want to. So next time, what I want to handle is I want to look into streaming in data to the JSON parser and not just using a preloaded buffer. That would be great. So yeah, I think that's what we're gonna do next time. Unfortunately, sorry we couldn't get the actual game code itself, but part of game development is doing the research to figure out how to do like the basic stuff that you need to get done before you can move on to the more exciting stuff. But anyway, yeah, for anyone that stopped by, it's much appreciated as always. If you're new here, I think I'm going to go ahead and share our project. And I won't submit any of this code because it's just kind of test code for myself, unless people actually want to keep it for posterity's sake. Or maybe I should keep around a directory of this prototype code. That's not actually used to build the game, but it is used to learn how to program in Zig and other kind of tests that we need to perform to just learn. Maybe I'll do that. I don't know. But anyway, here's our project. And if, again, you've never been around before, you're new to the stream, we do have a Discord where we chat about this kind of stuff. Not much activity lately, but I do keep people up to date about when the stream's going to happen and some other related stuff. I share some stuff related to Zig and maybe game programming. Yeah, let me just post an invite into the chat here for anybody who's missed out on that. And whoops, I didn't want to. Is that right? Yeah. So that should be our Discord link. And feel free to drop by and say hi. But other than that, I think I'm going to finish up for the day. As always, I really grateful for everybody who stopped by, and especially when you say something in the chat. Unless there's any other questions, I think I'm going to finish up the stream here. And yeah, I hope everybody has a nice day, or evening, depending where you're at. And I got to finish off the rest of my day here, it being morning. So yeah, until next time, thanks for dropping by. See you all soon.